Hi everyone, this is the video lesson for 5.7 Trig Identities Day 2 Part 2. If you haven't watched Part 1 of Day 2 yet, please go back and watch it before continuing. Now last time we stopped at example number 3, let's continue. I started with the right hand side, 10x plus secant x quantity square. So you really want to begin with the end in mind and reverse engineer. Notice on the left hand side, it says 1 plus sine x divided by 1 minus sine x. So all you're looking for is everything in terms of sine x. So the first step is to rewrite 10x in terms of sine x over cosine x. And likewise, if you think about secant x, that's 1 divided by cosine x. The whole thing, quantity squared. If you combine this as one fraction, this will give you sine x plus 1 divided by cosine x quantity squared. Now, I'm going to make a mistake. This is what happens if you don't begin with the end in mind. For some students, they look at this and they say, oh, expanding. I know how to do this. That's a perfect square. And they start writing sine square x plus 2 sine x plus 1 divided by cosine square x. And again, if you did this, you are perfectly fine. You are more than enough. You're not a mistake, but you actually made a mistake. And it's okay because mistakes are our friends. Now, look at the left-hand side. You want 1 plus sine x. We already have 1 plus sine x. So do not expand and move on to the next step. You're now going backwards or you're going around a circle. So instead, what you should do is keep what you want and fix everything else. So what I mean is this. We want 1 plus sine x. We have that. And if you're going to square this, that means there's another 1 plus sine x you're going to multiply. And that's okay. You look at the bottom, that's cosine x squared. And of course, I'm going to highlight this to make sure it's very clear. We want 1 plus sine x. We have 1 plus sine x. So do not do anything with that. Don't expand, just copy. If you keep going, look what happens. I copy the top, and if I look at the denominator, I can rewrite cosine square x as 1 minus sine square x. And again, step 5 says factoring, very, very useful. If you look at the denominator, 1 minus sine square x is the same as 1 minus sine x times 1 plus sine x. And of course, if you look at the top and the bottom, you can cross out the 1 plus sine x over itself. And now, this is exactly the same as the left-hand side, just like that. Let's keep going. Example number 4. Again, begin with the belief that you can do it. Belief is number 1. Action is number 2. Prove the following. So 1 divided by 1 plus tan square y plus 1 divided by 1 plus cotangent square y equals to 1. So start with the left-hand side. I'm going to copy this. Again, there's some shortcuts that we can show you. And you should know this with practice. So again, if you haven't watched the first part, I'm going to go back just to give a little summary or the update. Notice how 1 plus cotangent square x equals to cosecant square x. So this means you can rewrite this as 1 over cosecant square y. Likewise, if you look at the bottom here, tan square x plus 1 equals to secant square x, which means you can rewrite this as 1 over secant square y. And again, with practice, you would know this by heart. 1 divided by secant, of course, is cosine. So in this case, it would be cosine square y. Likewise, 1 divided by cosecant is sine. So this is sine square y. And of course, from day 1, part 1, you've learned this equals to 1, which equals to the right-hand side. Number 5, secant x plus tan x equals to 1 divided by secant x minus tan x. The more difficult side appears to be the right, Just start with the right-hand side and just copy, just like that. Now again, this is one of those questions where it's a little bit difficult. You could practice the move if you want to multiply the top and the bottom by secant x plus tan x, or you can rewrite this in terms of sine and cosine. It's really up to you. I'm imagining most of you will rewrite this in terms of sine and cosine, so I'm going to use the more common method, and hopefully this will connect with you. Secant x becomes 1 over cosine x. Tan x equals to sine x over cosine x. Again, you want to combine them as one fraction. One you can copy, or you can write down 1 over 1. In the denominator, that's going to be 1 minus sine x divided by cosine x. And of course, a fraction divided by second fraction means you take the reciprocal of the second one. So this becomes cosine x divided by 1 minus sine x. Now again, you have to look at the left-hand side. You have to look at what you have so far and figure out what is the disconnect. What do we have to do? So the big picture is this. If you think about secant x plus tan x, this is really 1 over cosine x plus sine x over cosine x. So the common denominator is going to be cosine x. So to do that, you have to practice what I call the move. You can multiply the top and the bottom by 1 plus sine x divided by 1 plus sine x. And again, effectively, you're multiplying it by 1. You don't change the value of the fraction. Now, again, look at the denominator. A minus b times a plus b, that's a squared minus b squared, that's 1 minus sine square x. Copy the top, do not expand this. And again, if you think about 1 minus sine square x, that is the same as cosine square x, or cosine x times cosine x. And now you can cross out cosine x from the top and from the bottom, just like that. And when you now break this apart into two pieces, you get 1 over cosine x plus sine x over cosine x. And again, this is exactly what you're looking for. Secant x plus tan x, which is equal to the left-hand side. Again, I'm not saying this is the fastest way, but I imagine most of you would rewrite this in terms of sine and cosine, so I'm navigating it through what most of you would do. One more example. Let's finish strong. Cosecant x to the power 4 minus cotangent x to the power 4 equals to 1 plus cosine x squared divided by sine x squared. Again, the more difficult side appears to be the left, so you can copy it first. When you look at the right, notice the exponents is 2. So it's going to be something square, something square. So there's no power of 4. So the first step is you want to factor using difference of squares, which means this is cosine or cosecant x squared minus cotangent x squared times cosecant x squared plus cotangent x squared. Again, if you look at the right, which is beginning with the n in mind, everything is in terms of sine and cosine. So cosecant x becomes 1 over sine x squared. Cotangent x, or cotangent x squared, it's going to be cosine x squared divided by sine x squared. And if you look at the second fraction, same idea. 1 divided by sine square x plus cosine square x divided by sine square x. Now, combine them as one fraction. In the first case, the bottom is going to be sine square x. If you look at the top, that's 1 minus cos square x. And in a moment, you will see how that's exactly 1. In the second part, that's 1 plus cos square x divided by sine square x, just like that. Again, 1 minus cos square x is sine square x divided by itself. In the second fraction, just copy it. And now, when you look at this, the first fraction equals to 1. And now you get exactly the same as the right-hand side. So, remember, following this does not mean you can do it. And I'm saying this respectively because in most math lessons, if you follow something, you can probably do it on your own. But for trig proofs, it's almost the opposite. Following does not mean you can do it. In fact, if you don't practice, I can almost assure you, you won't be able to do it. But again, go back to number 4. Try to do this, starting with the right, even though this is probably not the best example. Some will just multiply the top and the bottom by the left, and that's it. On the second example, or example number 5, you can try doing this starting with the left. And example number 6, we do this starting with the right, or just we do number 4, 5, and 6 as is, just without looking. And of course, remember, your math skills are only as good as your last set of math homework. So try numbers 3 and 4, number 7 on page 398. And until next time, all the best, and I hope this makes sense.